Sorry guys, we're taking so long on Thursday to finish up the material. So as promised, I will post the YouTube version of this. So here we go. So some also quick notes here going back to the chapters here. We're also talking about the T1 carriers. These are basically point-to-point lines. You can get them in fractional T1s. The big note, maybe you want to make sure you know the speeds for T3. That's highlighted. You need a minimum of a Cat3 cable. And then you have RIP. RIP uses hop counts. So RIP is a routing protocol that routers use to advertise networks, so they know how to route information from one network to another network. So a couple of key things to know about RIP is one, it uses hop counts. Its metrics is up to 16 indicators that a route is unreachable. So once it hits past 16, it'll say, hey, this doesn't exist. RIP is also a distant vector routing protocol. It uses its metrics for hops. Basically, it's not sophisticated. So if you had multiple links to get there, whatever's the shortest path to get there, maybe not necessarily the fastest path, it's going to take the shortest, the least amount of examples like toll booths it has to go through. Then we have layer 2 point-to-point protocol. So this is where we're getting into making a virtual link between the networks. So the main thing you want to know about a P2P is it's used as a layer 2 protocol for dedicated leasing lines. And then here's some of the other things. So with the point-to-point protocol, you can see that we have the LCP, which is this job is to do link establishments. Then you have the NCP, which is layer 3. And then the two main things here is you can see that we have for authentication, we have PAP and MS-CHAP and CHAP. So you could see something would ask you about as far as authentication mechanisms. So then we have point-to-point protocol over Ethernet, which is PPOE. So here, this is used for DSL lines. Certain other internet providers or ISP providers, they will use this protocol to link you from one network to another. Wireless. So some of the things we should know about wireless again is wireless broadcasts an SSID number, so that way you can log in, authenticate, makes it easier. So here's some of the things that the book says about enabling the SSID broadcast. It makes it easier for intrusion detection systems to detect on your network. Disabling this will increase security. And that's partially good. Also, in the past, that will also have problems with some devices don't like networks that are hidden. So some legacy stuff you may have some issues with. And then also with the increasing security we have, the PSA technology, what we use is the personal mode. Then we have the IEEE 802.1x standard that defines the standards for authentication. So, like an example, like on the college, when you jump on the network, you put your student name, your password to get on. That's the technology behind the scenes that you're using to do that. Some fun things about network card redundancy. So you can have essentially two states. You can have active-active, where it means both network cards are on at the same time. And they each have their own MAC address. And then you have an active standby, where one NIC card is on at a time. So that means he's like, think of it like baseball. You have the primary pitcher pitching out there, and you have the backup pitcher warming up in the back and the bullpen. So if something happens, he can come right out and play. So another thing we measure HA, because if you're doing active standby, you're also going to be doing some high availability. That's what HA stands for, high availability. And we measure that in an example. A lot of people refer to the 5 nines. So that works out to be an example of 99.999% uptime. So that would be a good example of the HA. So ping. So we talked about ping earlier. We use that to administratively, it's a utility part. It's a part of the utility of TCP. That essentially is a command line utility that you run with ping space the IP address, ping space the name, like we talked about and showed you the examples of it. So like an example, you should know like option C specifies the number of pings that you can send. So in Windows, it'll send 4 pings. You could use the option C to change that if you want to. And then we use the old ipconfig command to use to release and renew IP addresses when we get them from the DHCP server, like the example I showed you guys on Thursday, the DHCP server. An example of some networking tools, a crimper. We use that to attach connectors on RJ45s on both ends of the cable. And then Simple Network Management Protocol, SNMP. So here's some of the different things. We have a set where we request information. We use a get. Send information, we use a set. And then we set an example traps to, from switches, routers that we would trigger essentially some type of situation happens, creates an alert, sends that out through the simple management protocol. So these are mainly used for, like I would term like appliances, like routers, switches, where they're not like a full-blown desktop, but they have like a mini OS, like printers, things like that, cameras. Those types of devices would use this technology to send its data. So we also again have 3 versions of the SNMP. So version 1 and 2 uses what they call community strings. So by default, there's a community string called public, which is read only, and then there's a private one called that gives you the ability to read and write to the device. So by default, if you're using these 2 versions, you should change the default strings because it's pretty much the default ones to begin with. And then with version 3, they basically add encryption and authentication. So now you have to authenticate to get that information. And then here they're just showing an example of the 3 things that makes up the management node provisions that we use here. So you can see we have the SNMP application, we have the SNMP manager, and then we may have an agent. So we may have some type of agent that goes on a certain type of device that would pass that information to the management portion, and then we'd have the application. So that's the 3 components that essentially makes up this system. And then there's 2 primary ways, or 2 primary components for generating or collecting logs. One, you got to have a log server that houses all these events, and then you got to have clients to send the logs to the log server. So it's like, what happens, the chicken or the egg? Essentially, you got to have both for it to work. So you have to have one server at least, and then you have to have the client on how many devices, what devices you want to centrally store your logs, which is good because when something happens, you don't have logs, you won't be able to retrieve it. And then in the security world, we have the triad or the CIA, depending on how you want to look at it. Essentially, we're going over confidential, integrity, availability. That is a goal for a network security goal, is to support this. And then ACLs. So ACLs is what we set on routers, firewalls, can do this a certain level on switches, depending on the model of switch you're using. And you can filter by source, destination, ports, like the example I showed you when I did the example of the Palo Alto firewall a couple weeks ago. So this is basically how you lock down your traffic. What do you want to allow out of your company? What do you want to allow into your organization? What do you want to allow into the DMZ? Who can talk to these devices? That's essentially what your ACL is. It's like a pegboard. It's a rule base. It just essentially starts with rule 1, 2, 3, 4. Whatever it matches, that's what it runs with. So the one big thing everybody should always know about ACLs is the last rule that you don't see is deny, 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 deny. So if whatever this packet coming in, if it didn't match any of the rules, well, the last catch-all rule is deny everything. So this is an example of using an access list on a Cisco device here. Here you can see they're creating an access rule 100, and they're saying with this protocol from this IP going to this particular IP on these ports, allow it or not allow it, depending on the rest of the configuration here is. And then we have packet filtering is basically the sort of the first, second generation of a firewall. And then, most common algorithms we use is the SHA-1, MD5 are the two most common hash algorithms. RSA is the most popular. Asymmetrical encryption. So this would be like an example. You go to the bank, you get the little padlock on the browser. It's using the RSA. And then having an instant response policy is a commonplace policy that should be considered in every organization. As far as related to IT related operations, every place needs to have one. If you're dealing with some kind of policy, you're pretty much going to be dealing with that. So some of these other things you should have for remote access policy, they tend to cover up dial-up, VPN portals, anything that's going to give somebody access from the outside back into something would be those types of categories. So like here in the example I'm showing dial-up, VPNs. And then acceptable use, what is a fair use for using the network, things like that. Privileged user agreements, so this would be like you're the intro level IT guy because you're going to have more rights than a typical user is going to have, so you may have to have some type of agreement that you would have to sign to make sure that you understand what you're responsible for. Troubleshooting stuff. So the most common OSI layer 1 problems is bad cables, bad DB loss. That would be for wireless. Some of the most common problems in layer 3 would be, misfinger typing IP addresses or an incorrect subnet mask. Basically, something logical is going to be along layer 3. Common wireless, problems. Maybe, using with refraction or going through cardboard material that's going to lower your data speeds. It all depends. It all depends on when you set the wireless up, how did you do the survey, things like that. It's going to determine performance issues. So here's the book talks about what are some of the common ones that you should know. And then in switches we have spanning tree. So if we create two redundant links, we would use spanning tree to stop that. So one would be a primary, one would be standby. Here's 7 steps of going into troubleshooting. Gathering your information, it's a huge one. Understanding what is the problem. Interview the person. Figure it out. Find out if anything's changed. That should be one of your questions when you're interviewing them. And then attempt to repeat the process. So attempt to, have them show you what they were doing and see can they be repeated. And then once it's been repeated, then, go to the next step. Separate what does or doesn't work, approach it, you know, approach it in one direction and go like I showed you guys. All right, well, that includes the rest of the review. So good luck. I will see you guys next week. So there is no class on Tuesday. So I will see you guys on Thursday. I will be in office. I will be in the classroom by 12. So if you want to come in early and take it, I might be there a little bit earlier than 12, but that's when I normally am there at 12. So I will see you guys then. Thanks. Bye.